started a recording. So we'll go to individual components. So mainly three ways we can able to talk, like what is a CPU, what is there, what are the things we can look at a CPU, like if you want to upgrade, downgrade, what are the different manufacturers, and issues, what are the possible issues we will get it. If CPU got corrupted or a problem is there, so what kind of issues we will get it. Okay, so that is will try to talk. What is CPU? It is a brain of the computer. It is a brain of the computer, and it is a central processing unit. What is CPU? It is a central processing unit. It is a semiconductor device or anything. It's just a small chip. Main function of processor is arithmetic and logical functions. So it will do arithmetic calculations and logical. Arithmetic means plus, minus, multiplications, divisions. These are all arithmetic. Logical means AND operation, OR operation, NOR operation, NOT operation, NAND operation, XOR operation, XNOR operations. These are logical operations. Okay, so it will do logical and as well as arithmetic operations. Guys, normally CPU does not understand any kind of language. CPUs are look like this, but it is a chip. It built in some instructions inside. Okay, and in a first part I showed. So the CPU, if you are searching for a CPU, how to search for a CPU model, what are there inside, like that. So there is a built-in instructions in a CPU is there. What is built-in instructions? So whenever it is taken in any input, it understand what is the input and the instruction of the input inside the input. It process according to it. To understand it, there is a built-in instructions are inside. Okay, so it is completely a semiconductor device, means it's a build based on a transistors, MOSFETs, exactly say. So every processor having a desired clock speed is there. Already I showed in my processor, my processor clock speed is, it is a 2.6 gigahertz clock speed. So every processor having certain clock speed, operating clock speed it is. And every processor is either it is a 32-bit processor or a 64-bit processors are there. Nowadays, maximum processors are a 64-bit processors only. Maximum processors are a 64-bit processor. You know, earlier days in a Intel mainly manufacture almost all processors, means for a very length of the time they launched 32-bit processors only. Okay, so there are a lot of histories there. Okay, yeah, here it is. I've written that history. You know, Intel launched a 4-bit processor. The number is 4004. Then second processor is 8008. It's 8-bit processor. This is just for a knowing purpose only, guys. Not like you should write somewhere and by heart something. Not required. Just for understanding purpose only I've written. Okay. So later on days it is 8080, 8081, 8082. And finally they made a 8085 processor. After that one, 8086 processor is there. So there is an important two processor revolution, that is 8085 and 8086. So when it is 8086, okay, there is a lot of difference between previous processor to 8086, like a pipelining technology is introduced. Okay, non-accumulator based calculations. Okay, it does not depend upon accumulator things. Registry based calculation. So new technology is a complete, the structure of earlier processor is changed. So that's why it is become a more standard, and 8086, 80186, 286, 386, 486, 586, Pentium 1, Pentium 2, Pentium 3, Celeron, Pentium 4, Pentium dual core processors. Okay, Pentium dual core processor, M means mobile editions. Pentium M processors also there. i3, i5, i7, i9. Xeon processor mainly used for this type of processor for servers purpose. They are used. Okay. So because of in Intel, as per the Intel, this is the different type of processors came from 4-bit, 8-bit, 16-bit, next 32-bit, and 64-bit. So first processor is 4-bit processor, then 8-bit processor, then 16-bit processor, then 16-bit processor, 16-bit processor. These are 60-bit only. 32-bit processors are came into market later. Then next 64-bit processors are came into market. So because of this evolution, so 32-bit, not a 32-bit, Intel to represent any processor, it is an Intel processor. It is a Intel processor. They use a code called a x86 means Intel processor. x86 means Intel processor, and Intel processor every year they release a number of different 32-bit processors are high. So obviously there has become a habitual stamp is occur. x86 meaning is it is a 32-bit processor, and also this is also represent it is a 32-bit processor or 32-bit application, 32-bit operating system, application, drivers, and hardware means processor. The representation is become like this. Next is x86 underscore 64 represent it's a 64-bit processor or it's 64-bit bit operating system, 64-bit application for a Intel processor. So this represent Intel processor. This is 64. This is Intel 64. Okay. So x86 or 86 is become standard code for representing Intel. And some places people use x86 for representing it is a 32-bit. x86 use it to represent it is a 32-bit. So what about AMD? AMD is 32 bits are very less, 64 bits are more high. So usually for 64 bit they told AMD 64. Okay, so AMD 64 application means the application is 64-bit application runs on a 64 AMD processor. It does not mean it won't work on Intel, but that represent like this AMD 64. Okay, so this is the way in a processor and application operating system. So the 32-bit, 64-bit representation. Of course, there is the differences are there. We'll come back to that one. So every processor having a bit 32-bit processor or a 64-bit processor. Of course, 16 we are not using now currently, right? So compulsory check if any processor you are get. But so compulsory check it is a 32-bit processor or a 64-bit processor. FSB front side bus. Okay, every processor having a two buses are there, front side bus, back side bus. So FSB speed is different from your BSP speed. Speed or a BSP speed. So this is a BSP speed. 2.6. This is the BSP speed. But front side bus FSB speed is different from regular speed. What happened? Yeah, here it is. Don't touch it. FSB speeds are different from BSP speeds. Okay, so what is this FSB? FSB, I will the entire system applications everything become slower. So FSB means this is the processor and here it is a RAM. Okay, processor to RAM communication. Okay, the communication data transmission speed between processor to the RAM Okay, processor to the RAM is, it use a clock speed to transmit the data, right? Transmit and receive the data, that is FSB, front side bus. What is front side bus? CPU to RAM, front side bus. Okay, so that is a FSB. Next, cache memory. So what is the cache memory? Every processor having a cache memory. So these cache memories are in different levels, like a level 1, level 2, level 3, like a level 1, level 2, level 3, like this. This is cache memories are there. So originally, when your processor is communicating, means putting a data into the RAM or taking a data and instructions from the RAM, first it load into this cache memory only. This is cache memory. So your RAM load data into cache memory, and RAM take the data from cache memory. Processor take the data and instructions from the cache memory, okay, and load the data and instructions or data or output. After processing, it put it into cache memory. Means original main CPU won't communicate with the RAM also directly. It communicates through the cache. Means it's a double loading again. CPU to cache, cache to RAM, RAM to cache, cache to CPU. So this is what happened. Higher the cache, faster the processing. Higher the cache, faster the processing speed. So that's why I always check the your L3 cache, because L1, L2 standard cache speed, but L3 cache is there. Like you can go to CPU. This is my L3 cache, 3 MB. L1 cache, L2 cache, L3 cache. So your cache is having more size, bigger the size. Okay, bigger the cache size, faster the processing power. Now, next about a processor. Each processor okay. So each processor is a single processor. It's a, earlier days they use a single processor like this. This is a single processor, one CPU kind of stuff. One CPU, one chip. It is a physically a one chip into one socket. Normally, any desktop computers, we have a one socket on motherboard, one CPU on motherboard. So when server required a more processing. Server required more processing, so they required more CPU on it. So what they do, they build a motherboards to put a multiple CPUs. We can able to put it. Okay, so they can easily put multiple CPUs. So because of multiple CPUs, so automatically the processing power increases. But it is a challenge is always there, because it's a cost. Their cost of. Next, not only a people, not only a server, also normal people also having a challenge. But it is. I selected this one only, right? Okay. Okay. People need more computation. So what happened? The Pentium 3, Pentium 4 processor launch, but still people need more power processing. So they cannot able to design the very big processor with a limited size. So what they done, they created this dual core technology. Means there's a two processors are combined together like this. There is a two processors are combined like this. There's two processors combined like this with a single cache memory. So this is the dual core processor. So whenever instruction is loaded, they share the load of the instruction and process it. The speed of the processing is become higher. So next one is what they done. They take one single processor. So instead of taking two processor and combine, they take single processor. They divide the processor into two parts. They divide this processor into two parts. Like this is a core 0. This is core 1. This is core 0. This is core 1. It's a single CPU divided into two parts with a separate cache memories. So what is the advantage of this? It's become a dual core. So this is dual core. This is a core to 0. Okay, the model is like a core to 0 model. This is dual core model. Means a processor is divided into two parts. No. It's a two processor combined together with a single cache memory. But here it is. So core to 0 means single processor divided into two parts with a separate cache memories. Means multitasking become more easy here. Dual core speed of the processor is faster execution of the programs, but it is multitasking. Multiple programs can be easily executed in a fast way. So no more loading, waiting conditions will be reduced. Okay, so that is the main point of this dual core. The next type is like this. They divide one processor into four parts. This is called a quad to core. This is called a quad to core. 1 second, guys. Okay, sorry. So there is a it is like a quad to core, means single processor, quad core processors. Now we are having a octa core processor. Octa core means we divide four each. Is like a, I don't know why it is not working. So it is a single processor. We divide into four, and of course double divide. The double division means it is one processor is divided into 8 parts. One processor is divided into 8 parts. I don't know how to divide 8 parts. Okay, so maybe if you take bigger also it's difficult. This is big. So how to make it as a 8 parts, like maybe 2, 3, 4, 5, 6, 7, 8. Okay, maybe like this, or maybe like side by side, or maybe this kind. So what is this diagram? This Butler diagram is a threads. Thread means this is a two cores, right? So one processor divided into two cores. Each is divided into another one. Again, become as another one. So it means one become two. This each one become another one, means it is like a become like a 4. It's a 2 core, 4 logical processors. Okay, it will become 2 core, 4 logical. It is a threading. multi-thread processors. That if your processor having a threading means it is very high performance. So this is a main point of core technology. So dual cores, core to 0, quad core processors, okay, octa core processor, deca core processors. These are all comes like this only. So the point is, in generally in a computer wise, okay. So the processor is divided into multiple parts. Is in each part we call it as a core. Each core are having their dedicated cache memory. So it speed up your processing speed also. Okay, and also verify your number of threads per the processor. So number of threads are high, like a 2-core processor, 2 cores, 4 threads, 4 cores, 8 threads, 8 cores, 16 threads. Like it, the processor is much faster and very costly. Okay, so these are the things. So these are this is about your processing model, but here one more point I am added, that is called a virtualization technologies. Guys, nowadays computer does not mean only for one single purpose. Okay, so how can we differentiate a computer from a thing is like a mobile phone or tablets? So everything we can able to do it in a mobile phone, and everything we can do it in your tablet nowadays. But one thing we can't able to do it, that is still we can't able to do it, that is a virtualization. So what is this virtualization kind of stuff? As one single point, there is a lot of points are there, but I am telling in my system wise, in my point of view, not in my point of view, out of virtualization, only one point I am telling here. Guys, my system is Windows 10 operating system. My system is Windows 10 operating system. For example, there is a batch, they want a Linux. So how to teach them a Linux operating system? So what I have to do? I purchase a new computer, install a Linux operating system, I have to share the screen so they can able to see it. Right? Now another batch is came. That is Windows Server 2019 or 2016. They're asking, sir, we want a Windows Server. So I need a one server operating system, one client operating system. So I have to purchase 2 systems here and install one system with a server operating system, another with a client operating system. So what happened here? I have to purchase a hardware. I have to connect a power supply. I have to connect a network connection, and I have to maintain a uh, screen sharing part first of all. Okay, right, we have to install operating system. So the cost and maintenance become very high now. Cost and maintenance. Next, I don't stay in one place. I don't stay in one place. I will be there in Pune for some few days, again in Hyderabad, again Visakhapatnam, again Pune, Hyderabad, Visakhapatnam. So as per my issues, so I have to go around. How to go around. So this is the point here. Next. Okay. Next is, what is this VMware Workstation or a virtualization kind of stuff? This is a VMware Workstation Pro. Is an application used to create a multiple virtual machines here. So I can create a virtual machine here. So then I can install an operating system. So I can able to show that one. For example, if you look at this is installed. This is a virtual machine with a Linux operating system. And here it is. This is the virtual machine. See, this is S1. It's a virtual machine. It is installed with a Windows Server 2019. This is the Windows 10 virtual machine, which is I installed Oracle applications inside. Okay, so this is a Linux operating system, and also inside I installed some DevOps tools inside, including Ansible. Okay, so here it is for my practice purpose. You can use a old operating system. Sometimes I need to show some practicals in a line XP. So then I can show here Windows XP is there. This is a 2003 server, Windows XP operating system, 2003 server, 2012 server. This is a 2012 server. Like this, one single system, you can run multiple operating system in the same physical machine. Okay, so what is a virtualization? Very simple. In the virtualization means only one statement, guys. There are a lot of statements are there, so only one statement I'm telling. So in here in my desktop, a single physical machine can able to run multiple virtual machines, means multiple guest operating systems. So here I am putting a point. It is single desktop or a physical machine we can run multiple virtual machines. We can say guest OSs. What is guest OS? Guest OS means OS running in virtual machine. Host OS then. Host OS means OS in physical machine. So my host OS is Windows 10. My guest OS is Linux, Windows servers, different operating systems. Okay, so this is the point. Here it is. Virtualization, guys. To do this thing, to run, you want to run a virtual machines in your single physical machine. You have to make sure this virtualization is enabled or not. So go to taskbar, task manager, click on performance, click on CPU. So this is a virtualization is enabled or not. So compulsory check this one. Okay, so that's the point I'm trying to say this. So virtualization technology enabled or not. Okay, so here it is basic information of your CPU. Different manufacturer of CPU are there currently in the competition. Intel processors and AMD processors are there. VIA and Motorola is almost very less. Motorola also mobile processing. First mobile processing by your Motorola, and still there is a certain things like Cisco routers, switches. Their processors also manufactured by your Motorola only. Next, here it is 32-bit, 64-bit. How it is represent, I told, but there is a futuristic differences are there, guys. First of all, understand system architecture with a 32-bit or a 64-bit. Your CPU, your processor is 32-bit. This processor is 32-bit. So instruction set is 32-bit. Your drivers, device drivers, this must be 32-bit. Your operating system must be 32-bit. Applications, better 32-bit, not 64-bit anyway. So compulsory, your processor is 32-bit, OS 32-bit, device drivers 32-bit, and applications 32-bit, optionally 16-bit support. Next, if your system is 64-bit, means your processor is 64-bit, your processor 64-bit, operating system 64-bit, and applications also 64-bit. I'm changing a little bit. So compulsory processor, the CPU. Once CPU is, there is a point of, yeah. So instruction set is 32-bit in a 32-bit processor, 64-bit in 64-bit processor. So if your CPU is 32-bit, OS must be 32-bit, operating system 32-bit drivers, device drivers must be 32-bit. Your processor is 64-bit, operating system 64-bit, device drivers 64-bit. But applications having small facility, it does not support higher bit. Means 32-bit CPU, 32-bit application, good. 32-bit CPU, 32-bit OS, 32-bit CPU, 32-bit OS, and 16-bit application with a certain additional things like a wow 32 kind of features we can run. But it won't support 64-bit applications. 64-bit application you don't support. Your processor RAM is 64-bit, application must be 64-bit, then it is good. You have an application called 32, so 32-bit application is there, so you have to work with a wow 64. Otherwise, go for a, okay, there is no 128 yet, okay, in a processor. Of course, 128-bit processor is there, but in generally in our market wise, we don't have any like home users, we don't have any 128. So simply guys, compatibility means the architectural compatibility. One point is architectural compatibility, meaning is CPU, operating system, device drivers, and applications should maintain same bit number, 32-bit or a 64-bit, not end. So in a 64-bit, advantage of using 64-bit is multi-core processing. We are getting very easy way. So instead of dual core processing kind of stuff, multi-core processing, 8-core, 8-core processor, 4-core processor kind of stuff. Okay, multi-thread processing is possible. Virtualization technology feature is available in a 64-bit processor. Possible. Okay. In 32 it is not there. In 64-bit processor, 64-bit operating system, there is a virtualization technology is possible. It support UEFI. The latest BIOS version is UEFI. From UEFI, you will get a secure boot. And device drivers digital signature is enforcement is there. And of course, there is some other features also there because of 64-bit. If you are using 64-bit, instruction set is bigger, right? 32-bit instruction set is smaller. 64-bit instruction set is bigger. Data is bigger. Each data part is a 64-bit. Now, obviously, what happened? We need a bigger the RAM, bigger the disk space. Okay. Need more RAM size and disk size space also. Okay, need more. Now comparatively 32-bit, you need a more RAM and disk space also. Okay, so it is not an advantage. It is like it's look like it is what disadvantages, but very high complex programs we can easily run. You know, in our olden days, you want to run what is that? PS means Photoshop. You want to run a Photoshop, you need a RAM, processor, lot of time hanging, that much of this requirement, that requirement, like that. So many are there. Nowadays, we are running very complex programs, very big programs very easily because of you are a 64-bit, so larger instruction sizes, so high complex instructions, we can create it and run it, and it will understand it. and of course we have to use a big RAM and more disk space. So obviously the larger the RAM and more disk space, we can store the data and as well as we can run it very easily. So these are the differences between 32-bit and 64-bit. Guys, are you okay up to now? Are you okay up to now? So you got some information about CPU. No one is telling anything. No one is understand anything. Not understandable.
Understood, sir.
Understood. Yeah. So first time you are learning after a long time. So it is little bit freezing is there. So um, almost like I have to attend another class. So I have to have lunch. So no problem, but small details I will tell. So don't waste time. So here it is. Memories also I will tell. RAM and ROM difference. Just I will tell RAM and ROM. And about a RAM, that's it. Okay, about BIOS, I will tell tomorrow. Okay, so I will tell about a RAM and ROM and as well as what is just basics of RAM. Okay, and other taking means issues we will discuss tomorrow. So tomorrow class at 10:30, guys. So, okay, so I will inform anyway. Any changes, I will inform. But usually 10:30. By 10:30, be ready. 10:15, be ready. Okay, 10:15, be ready. Be always open your WhatsApp because of not only me, Ravan sir or Sudeshna madam also will communicate, right? Of course, you have a class in afternoon. I will complete this faster. So you can look at here. RAM and ROM are a primary memories, guys. RAM, random access memory. ROM, read-only memory. RAM is a volatile memory. ROM is a non-volatile memory. Non-volatile represented in a NV. NV means non-volatile. NVRAM, non-volatile RAM. NVMe, non-volatile memory. So non-volatile. So what is a volatile? Volatile means like you power off your system. So whatever the data in the RAM will gone automatically. So what is a volatile? So when you power off your system, turn off your system, data will be lost. ROM is a chip. Chip means the built-in data is there. Built-in data or built-in instructions are there or built-in programs are there. Even if you shut down your computer, the program inside your ROM chip won't be gone anywhere. So that is like a non-volatile. For example, your hard disk is also kind of non-volatile. Okay, that storage related. But ROM is a non-volatile kind of stuff. Non-volatile, there is a lot of things are there, but your ROM is a chip. Meaning is the chip already built with some instructions inside. Okay, so obviously it is not a read and write kind of stuff. RAM read and write. RAM is a read and write. ROM read only memory. Read only means you can read it, but you cannot change anything. So if you power off, nothing will lost in the ROM chip. Of course, there is a BIOS related information is there. That is we'll discuss later. Okay. So we can RAM load the data from IO devices like this. This is the diagram. Your RAM load the data from your IO controllers. So IO controller means it collect the data from your IO devices or give the data to IO devices. Okay, so IO controller to RAM data will be passes, data and instructions. RAM to CPU cache, CPU cache to CPU, and CPU process the data based on the instructions and data and give it to cache, cache to RAM, RAM to things. So you cannot give a instruction to CPU directly. You have to, if you are now you given typing something from your keyboard data collected by IO controller and give it to your RAM load it to CPU process it and generate the data and give it to the RAM. So RAM give it to IO controller. It shows on your monitor. Okay, this is the basic function. Again, we'll go back. RAM and ROM. What is the difference, guys? RAM is a random access memory. ROM read-only memory. RAM is a volatile memory. ROM is a non-volatile memory. What is a volatile means? Whenever the power is off, data lost. What is non-volatile? Even the power is off, data is still available. Okay. ROM is a chip. It is a fixed chip which we are not able to change randomly. Okay. ROM is a read and write type. So it is, we can able to change the RAM. We can add the RAM. Like I add 4 GB plus 8 GB. So it will become 12 GB. I can able to increase my RAM capacity. I can decrease my RAM capacity. I can able to replace the RAM. So these are the differences. Is having any doubts? So small points in a RAM, random access memory, also called, it is a primary memory and as well as a main memory. Okay, so already I explained how it is data stores. It stores the data is a temporary manner. So it's not a temporary or a permanent kind of stuff. It is like a fetch the data and give the data type. Means it is like a, if you see, this is a very big well and here is some drum is there. Okay, there is a well with the water and there is a big drum. Here is a small bucket. Okay, it's a small bucket. I fetch the water and pour it. So while I'm carrying water in the bucket, while I'm carrying the water in the bucket, after pouring, after poured, I poured the water in this one. So obviously bucket is empty. So again I'm fetching. Again I'm fetching and put it here. Means when I'm fetching, it is full. And I poured, it is empty. Meanwhile, it is there. So that's why it is it's a temporarily store the data. So we should not store the data permanently in the RAM. Why? Because the purpose is like that. It load the data and give the data to, it load the data and give the data to processor and processor to RAM, RAM to devices. So it's a volatile memory. RAM have two types. One is a static RAM, another one is a dynamic RAM. This static RAM is called as SRAM, which is actually, it is a cache memory, used as a cache memory inside of your CPU. So your CPU, this is complete CPU part. In built-in CPU only, this cache memory is there. Inside the CPU, cache memory is there. The cache memory is nothing but your RAM, which is SRAM, static RAM, which is very faster than dynamic RAM. Static RAM is a faster than dynamic RAM. So dynamic RAM is also called as DRAM. These different type of DRAMs are there. SDRAM, ECC RAM, EDO RAM, VRAM, NVRAM, Rambus RAM. So different type of RAMs are there. RDRAM. So I didn't written here. That is RDRAM, Rambus Dynamic RAM. But important is the dynamic RAM, DRAM, is developed as a SDRAM. Means synchronous dynamic RAM. Synchronous dynamic RAM. This synchronous dynamic RAM is much better than a DRAM. Okay, because the faster the data synchronization, loading, and giving kind of stuff. So like that. So it is a cheaper than SRAM. Next, this SDRAM further developed into DDR SDRAM, double data rate. DRAM, dynamic RAM, SDRAM, synchronous dynamic RAM, DDR, SDRAM, double data rate, synchronous dynamic RAM. Then it is next version DDR2, DDR3, DDR4 is released into the market. But there is a recently I found there is a 12th generation processor like i3, i5, i7, 12th generation processor release in a certain number. It is supporting DDR5. So when I seen, so I got this information, right? There is a DDR5 is also is released into the market, DDR5 type of RAM. Okay, so DDR6 still not there. DDR6 graphic card again. Graphic card different. So GDDR3, G DDR3, G DDR5, G DDR6. It's a graphic card related memory. Okay, it's not separate one. So if you purchase a graphic card, it contains a processor as well as a RAM inside that graphic card, right? So the RAM size they are showing, that is GDDRs, means the graphic card related RAMs. So do not get confused with both of things. Okay. So RAM, static RAM, dynamic RAM. Static RAM, SRAM, used as a cache memory, which is inside your CPU. Okay. So dynamic RAMs are DRAMs, which is slower than SRAM, but cheaper than SRAMs. DRAMs are further developed into SDRAM, and SDRAM become DDR, double data rate, DDR2, DDR3, DDR4, and finally DDR5. RAM specifications, always you have to look at RAM sizes. 5 GB RAM, 4 GB RAM, 16 GB RAM, always is like that. 1 GB, 2 GB, 3 GB, 4 GB, like that. So 1 GB, 2 GB, 4, no 3. Direct 3 GB won't be there. Okay. So 8 GB, 16 GB, 32 GB. Okay. So RAM sizes are there. And each RAM, every RAM. So 12 GB won't be there. 16 will be there. But how 12 is happen, how 6 is happen, how 3 is happen. So how it will happen is because of combination of two RAMs. 4 plus 8, 12. 4 plus 2, 6. 10 plus 2 are 4 plus 4 plus 2 are 8 plus 2, 10. 8 plus 2, 10. Okay. There is no minus thing here. Okay. So 4 plus 4, 8. And directly 8. 8 plus 8, 16. 16 plus 4, 20. 16 plus 8, 24. So the combinations, if you see total memory is different from the original direct single memory. Okay. So sodium packages 1600 megahertz speed. Okay. My processor is 1600 megahertz speed. It is like this: 133 megahertz, 16 megahertz, 2. So it is 2100 megahertz, 2400 megahertz, 3200 megahertz, 3000 megahertz. That kind of frequencies are there. And voltage levels, low voltage, high voltage kind of stuff. Low voltage means 1.3 volts, high voltage means 3 volts. That's it. Not high voltage means 10 volts. Okay. So when you are upgrading your RAM, you want to replace the RAM or upgrading the RAM, compulsory check compare with your CPU model support and motherboard. So type of RAM it will support. A motherboard, I have a motherboard, it support DDR4. I want to insert DDR3. We can't insert. We can't insert. So I want to insert DDR3. We can't insert DDR3. Okay. So it is a support for DDR4 only. Okay. So that is a thing. Next, I want to insert a 4 RAMs. There is only 2 RAM slots are there. So I can't able to insert it. So be careful with that one. Next, CPU support. My CPU support only 16 GB RAM. I want to try for 32 GB. Won't support. My processor support up to 32 GB. I use only 16, no problem. But if I want to go with more, it is a problem. So speed of the RAM, speed matches means this RAM speed and CPU FSB speed should be matches. CPU, FSB and RAM speed must be matches. Okay, that is we can check it. So better always check with your old RAM. So I am using a system. Okay, so already there is a RAM. It is running fine. So you want to upgrade or you want to replace. Go through your old RAM and take the RAM into shop and check it. I want this kind of RAM. So it is very easy to understand what RAM you require. Okay, make sure that your old RAM and new RAM frequency matches, type matches, kind of stuff. These are different RAM packages are there, guys. So SIM package, DIM package, RIM package, SODIMM packages. Single inline memory module, dual inline memory module, Rambus inline memory module, small outline DIM packages used usually for laptops and mini PCs. Each RAM having a different pin numbers are there. So depends upon the pin numbers also you have to insert the RAM into your processor. Okay. Yeah, I already about a static RAM and I explained this part also. So next is a ROM. Okay. That's enough about your RAM, guys. So find out what are the RAM related issues, CPU related issues we'll face in a computers. Okay. Find out the questions at least. So by question wise also we can able to discuss. So this is about your RAM, random access memory. Already I told ROM is a chip, read only memory. So it is directly on your circuit. ROM is developed into PROM, programmable read only memory, EPROM, erasable programmable read only memory, EPROM, electrically erasable programmable memories. So EPROMs are rewritable, means you load a data or instructions inside and you can change it also. That is a EPROMs. Okay. So there is a specific sizes of ROM chips are there, but in generally in a computers, we don't check the size of the ROM. We check the size of the RAM, but we don't check the size of the ROM chips. Okay, it's a 10 MB or 20 MB or 50 MB. We don't check the ROMs. So we don't specify the size of the ROMs. Okay, it is because of it is a built-in chip on your motherboard. Okay, it is all directly on motherboard. Of course, it is a rewritable. We can change the program, but generally we don't do it in a general manner. We don't do it. We can upgrade. And there is a program inside of this ROM chip is called a BIOS or UEFI, which is nothing but a firmware. BIOS is a basic input output system. That's it. Up to here. So tomorrow we'll discuss it from the BIOS. Because of BIOS, boot processing, BIOS settings, BIOS batteries, how to go to BIOS settings, and other things we'll discuss tomorrow. Okay, guys, up to now.